Hello, this is Paul from Foresight Tech. In this lecture, I'm going to introduce how to approximate the integral. Why we need to do approximation? Because as the last topic we did, for some integral we call the non-elementary integral, right? For example, like this. Okay, so we cannot use the fundamental to directly find the exact value. That's impossible already. So we have to do approximation. And basically we have three basic types of approximation. And here is the first type, we call the midpoint. And later we have another two I'm going to show you. Of course, we already learned another two, which is the left endpoint or the right endpoint, right? So and this middle point is better than the other two, so we put here first, only the middle point. Can we see? So here is the graph. If we have a function y equals fx from a to b, we need to find the area under the curve, which is the integral. We need to find the integral. Okay, if we have to do approximation, so this is the graph. So we learned this before, alright? And the first uniformly cut into n pieces. N pieces, so a is x0 and then go to x1 to go to xn. Okay, and the delta x, the increment from x0 to x1 or from x1 to x2, delta x equals b minus a over n. So I mean easy to determine xi first, and then the middle point. Remember, so x1 bar is the middle point of x0 and x1, which is the average of these two. x2 bar is the average of x1 and x2, and it goes on. And the formula is here. Okay, now the difficulty, we can find all the middle point, and then the value of the function at the middle point is the height of each small rectangle, right? Okay, so now we have all n rectangle. We use these n rectangles to approximate the area under the curve. That's what we call the middle point rule. Okay, it's very famous. We already have this formula before, see? And now the integral and the approximated by the middle point approximation, and with the n rectangles. So delta x is the increment, which is the width, right? The base, or simply you say the base times the height. So delta x is the base times the height. If we distribute, so the base times the height plus the base times the height plus the base, that's all the area of the rectangle. Okay, this is the formula. Later I have an example to show you how to do this. Exactly we did the one before, right? Okay, and we're talking about how good is your approximation. Here is the arrow bound, and we have an arrow bound for the middle point estimation, which is this one. Okay, this is the theoretical results, and you can find the proof. We did not provide the proof here, okay, or in the textbook. And if you go to Google to search the arrow bound for the middle point rule or approximation, you definitely find these results and find the proof. Okay, if someone interested, please go into Google to search. First, what is k mean here? Okay, k is the bound for the second derivative. Okay, and ban we know. See, we look at it. This is the basic bounds. If we know a, b, n, if we find the k, then definitely we know the maximal error will not this is the maximal error, right? So what is the error? We look at it. So this the error, this the error, this the error, this the error. So each small part. So sometimes the error is positive, sometimes the error is negative. However, we put all together the error. Or you simply can say this: the error is defined by the integral minus the approximation. The difference between the approximation is the error. Okay, so this is one result. It's a very beautiful result. Okay, in the history already. So now let's look at one example. How to do approximation. Okay, use this formula. So here is one example. Can we see? We do approximate. We do the definite integral However, this function, you know, we already learned this, right? This is a non-elementary. Okay, so the last topic already have this. It means you cannot exactly find the exact value using the fundamental, or try to find the entire variable, which is impossible. Okay. Now do the midpoint rule to approximate the integral with the n equals 10, means 10 rectangle rounded to 6 decimal places. So all we need to do is do what? Is build this table, okay, and finally use the formula here. And then let's look at the formula first. M10, the formula is delta x times, okay, here. So it means what? We need to find out what is delta x. We need to find the xi bar, or the bar midpoint, and then find the value. So how to do that? I build in the table. Okay, so we build the table. So first did the function, right? Okay, this is the function. So this is fx, no problem. This is a, this is b, right? So you know, we know ab, and then what is delta x? So we know delta x exactly is b minus a, right? B minus a over m. In our example, which is 2 minus 1 over 10, is 0.1. See, and the delta x is 0.1. We already find. How to find the delta xi? We have a formula to remember. Xi equals x0, which is 1a, right? And then plus I times delta x. That means the first x0 is 1, and then plus delta x. So 0.1, and then plus delta x 1.2, 1.3, that goes to the last endpoint is 10, right? X10, which is 2. You can easily figure out this term. The second, how to figure out this x bar? We definitely need x bar. X bar is this. Do you remember? X bar is the average of xi minus 1 plus xi over 2, right? This we put a bar. Okay, so we use this formula. Means x1 is the average of x0 and x1, which means 1 plus 1.1 divided by 2, we get 1.05. The same we find the average. Okay, so it goes on. We can figure out this column. And then do we have the function? Yes, we do have the function, right? The function going to evaluate the function at this midpoint. So we put all the value here, and they ask us to round to 6 decimal. So we round to 6 decimal. Okay, and this is a longer calculation, right? A lot of calculation. Whatever, if we already find this table, figure out what is xi, what is x bar, what is f at xi bar, and then we use the formula. This is 0.1. This is f at 1.05. We already have here, right? And have this value, or add this value together, and then times 0.1, and the final answer is 1.5. This is a kind of approximation. So everyone know, if you want to increase the accuracy, how to do? You have to increase n. Okay, if n goes bigger, then the error gets smaller. This is approximation. However, we have a calculator. So everyone look at a lot of calculation, right? However, we do have a formula in the calculator, which we call the table, right? We have a table in the calculator. We can do what? We can set up a function, and then it just put one column and this into the calculator. Apply the function to this column, you can find all the value directly. Okay. How to find the sum? We have one variable stats. If someone learned the statistic, how to use the table, that's easy to get, very easy to get the answer. Okay, so now I will going to show you how to do this. Okay, how to find this in the calculator. Okay, so here is my calculator. So can you see? This is 83. Okay, so Texas 83 instrument. Texas instrument 83. So if we have 84, is the similar. So what do we need to do? The first we do this. The first we type all this data. Okay, xi the midpoint into L1 column. I turn on. Okay. and the stats is going to input the data. The first added is input the data, and look at the L1 column 0.05.15 already type all the midpoint there. Okay, so this is the first step, and the second step you're going to define the variable, the function. What's our function? Is this function, right? We define the function here. We're going to y. Okay, I define already square root of x raised to the third power minus 1 is a function. We define this function in y1, in the variable y1 or function y1. That's good. And then we go back. So go back to the statistic, the table. What did you find? I was going to find all the value in L2, the second column. So how do you do this? Go to the right. We have to go to the top to apply the function. We add the function, go to variable. Okay, variable, go write the y variable. Say the first is a function, and then int. Okay, we define in y1, so int. y1 is the function. Parenthesis, the domain is L1, right? So we put the second one, parenthesis. See, this we apply the function into L1, and then int. Have you see? That's exactly the value of the function. I just type as put all here is exactly the same in the calculator. So now the last step, what do? We need to find all the sum. Okay, that means add all together. How do you do? Go to stat again, click, go to calculation, right? The first one variable stats is the function we need, and then int. Okay, apply, this is a function, apply to L2, which is second 2, right? Okay, and then int. Have you see where is the sum? Sigma x is the sum, is 15 point, and that's what we get all the sum. The last step is use the sum times delta x, which is times 0.1. What do we need to do? That's 15.18362229 times 0.1 delta x, and have 1.518, and this is the answer. Of course, we need to round it to 6 decimals, right? Okay, and that's all. Thank you.